Hello everyone and welcome to Adam Sharp YouTube channel. First of all, I am super excited and super happy that you have decided to take this brand new course, Swift Language Fundamentals. Now this is a mini course I have designed for all the developers that are stepping into iOS development, and obviously Swift is a prerequisite. So I have designed a course in a way that is really beginner friendly. And this is around 2.5 hour course that will teach you all the basic fundamentals about the Swift language. All right. Now, once you are finished with the course, your next step would be to continue learning more. So I have some free things more to give you. If you go to my website, adamsharp.school, and you click on the courses, after you finish the course, the Swift Language Fundamentals course, if you scroll down, you'll be able to get access to the SwiftUI Fundamentals course. Now, this course is going to teach you about SwiftUI Fundamentals, but make sure that you finish the Swift language course, that you have some idea about the Swift language before jumping into SwiftUI or any other thing. And check out some other courses. I mean, there are dozens and dozens of courses on Adam Sharp School, and I keep on adding brand new courses. Any topic that you think of, you will make sure that it will be on Adam Sharp School. I'm also hosting workshops. I have a course on Supabase. I have a course on full stack e-commerce app development, Swift architecture, Vapor. If you want to do Vapor programming, backend programming, I have a course on that. Core data, Swift data, reactive programming, MV pattern, test-driven development, macOS development, machine learning. So I have a lot of courses out there. Make sure that you try to check out these courses, and I have a very simple plan for monthly and annually, or you can just buy these courses on individual level. That's perfectly fine too. All right. So once again, thank you so much, and I really hope that you enjoy the course, the Swift language course, and share it with your friends, share it with your colleagues, and thumbs up, like, and comment. Thank you so much. Hope you enjoy the course. In this video, I'm going to show you that where you can download Xcode and how you can get started with creating iOS or Swift playgrounds so we can learn a little bit about Swift language. So I'm on google.com. So on Google, you can simply say Xcode. There we go. And you want to download Xcode from Apple. So there is Xcode over here, Apple developer. Let's go to that website. So this is the homepage for Xcode. And if you click on this download button, you can see Xcode betas or Xcode. Xcode. Download Xcode, not Xcode betas. Now, obviously, you're using a Mac. If you're not using a Mac, nothing will work for you. This course is not even for you. So make sure you're using a Mac. And when you click on that link, it will say Open App Store. Now, you can directly go to the Mac App Store and open it or download it. Now, obviously, I have installed Xcode, so that's why it says Open. But if you have not installed Xcode, it will say Install. So make sure you install it. Now, Xcode is a pretty big chunk or pretty big size. You can see 3.46 gigabyte. So it is going to take some time for you to download it. So make sure that you have time to download Xcode. Once you download Xcode, you can install it. I mean, it's just going to be an icon. You double click on it, it's going to install it. And next, launching Xcode, pretty simple. I'm going to say Command space. In a Spotlight search, I can just simply say Xcode. And that is going to launch Xcode for me. You can also go to Go menu over here and Applications. And you should be able to see Xcode. Since it starts with X, you will be able to see it right at the bottom, Xcode. All right, so let's see if I'm running it. This is it. Now this will be the home screen for when you're running Xcode. And what we want to do right now is to create a playground. So I'm going to say File, New, Playground. And iOS blank is okay. So we're just creating a playground just to learn the Swift language. Anywhere you want to save the playground, that's fine. And now you have created playgrounds. Playground is a really good place when you are just playing around with the Swift language, you're playing around with different frameworks, because you can simply press the play button. And the first time it actually does take a while to run the playground or whatever code you write. You can see it's now launching playground on the top. But after first time, it's going to be a little bit faster. Okay. And that's pretty much it. So you'll be using Xcode playgrounds just to learn the Swift language. And after that, we will be building our actual applications. In the last lecture, you learned about the Xcode environment and how to create playgrounds. Now we're going to start learning Swift language. And we're going to start with the very basics, which is variables and constants. And one of the great things about learning about this basic and the pillars of programming is that any language, or at least most of the languages that you're going to pick up to learn, they will always have variables and constants. So once you learn it in Swift language, you can apply the same exact concept because the concept is not going to change. You can apply the same concept in Java, Kotlin, Dart, C Sharp, and any other language that you want. So we'll start with creating a variable. Now the way that you create a variable is using the var keyword, V-A-R, var. And we will assign some sort of a value to it. I can say John over here. So now we have created a variable called John. Now the good thing about this variable is it's a var, which means you can change it. If you don't like John, if you want to assign some other value to it, you can do that, right? If I run this now in Playgrounds, just pressing the play button, and sometimes Playgrounds can take a while to run, so we're just going to run these 2 lines, and you should be able to see the result on the right-hand side. But as you can see, Playgrounds, first time when it runs, it's kind of slow, but Playground is an excellent place for you to learn the language or to just play around with frameworks. But yes, I do understand that Playgrounds can be slow. So hopefully when it runs, we'll be able to see the result of those lines on the right-hand side. So now you can see name, John and Doe is being printed over here. So we can create a variable using var, but we can also create a variable using let. You can see let pi equals to 3.142. So what's the difference between a var or a variable that is created using var and let? Well, let is a constant. What does that mean? Well, that means that you can't change it once you have assigned it, once you have defined it. So what is the value of pi over here? 3.142, right? And we have used a let keyword to define pi. If I go over here and change this value to something, and you can see that an error comes immediately telling me that cannot assign to value pi is a let constant. So we can't really change the value of variables that are defined with the let keyword. In other words, this is going to give us a compile time error, as you can see it's giving. All right. So this is the difference between let and var, or var and let. Var, you can define it and you can change it. Let, when you define it, it's constant, you can't really change it. Now another thing with Swift is the concept of type inference. We have already used type inference, but let me show you over here. Like over here, I'm saying city equals to Houston. But what is the type of city? What is the type of this variable? Is it an integer? Is it a Boolean? Is it a string? Now you might say, hold on a second, it's a string because I'm assigning it a value which is Houston and it's wrapped up in double quotes, which is a string. So city variable has to be string. But how? I mean, should I write code like this? Yeah, now it's a little bit clear that city is of type string and the value is Houston. But in Swift, it's not wrong by the way, but in Swift, you don't have to define the type. Type can be inferred based on the value that you're assigning. So the value that you're assigning over here is Houston. So the type of this variable called city can be inferred. Inferred means that Xcode or Swift compiler can automatically determine the type of this variable based on what you're assigning to it. Now, if I go over here and assign something else, let's say var distance equals to 12.75. 12.75, some sort of a decimal number, it will be double. So it will be kind of like this. But since it is type inference is built into the Swift language, you don't have to say double over here. If you don't say double, then it will still be double. All right. The same thing goes for if I create another variable called, let's say, is raining, and I can say Boolean equals to false. Do you think I can remove Boolean? Because the value itself, false, is kind of indicating that what this variable type will be. What do you think this variable type will be? Boolean, of course, because that's what we assigned it over here, right? So that will be the type of the variable. Now the common data types in Swift language are string. We have used it right there. We have integer also, a common data type. So var score equals to 100. But hold on a second. How can it tell? These two are numbers. How can it tell that this will be integer, score will be integer, while distance will be double? Well, look at the value that you're assigning. In distance, you assign the value 12.75. There's a point in there, dot. So it inferred it to be a double, but 100 is just a whole number, so it will be inferred as integer. All right. So that's it. So we learn about variables and constants and type inference and some of the common types in Swift language. Now, in the next lecture, we'll be talking about operators and expressions. Now let's go ahead and talk about operators and expressions. We're going to go ahead and assign some values to some variables. Let a, let b equals to 5, and we'll do a sum using the addition operator, which is just a plus sign. So this is kind of easy to remember because plus, even if you're from high school or middle school or elementary school, you have been working with addition, subtraction, division, multiplication. So it's the same thing, a plus b. So 10 plus 5, 15, right? And the same goes for the difference. So if I want the difference, so I can say difference equals to a minus b. So we can have this operator over here. And then we can have a product, meaning a multiply by b. A multiply by b using the asterisk sign. If I want to divide, so I'll say quotient, T-I-E-N-T, a divided by b. All right. And the remainder, don't forget about the mod operator with the percentage sign. And the great thing is that right now you're learning Swift language, but even if you're learning a different language, it's going to be the same exact meaning for these operators. And pretty much most of the programming languages will have all of these operators. Now, apart from that, we also have comparison operators. So I can go over here and create x is equals to 7, meaning x is assigned a value of 7. Can you guess what will be the data type for x and y? Remember we learned data type inference in the last lecture? Integer. Great. So first of all, equality operator or equal. So is equal equals to x equal to y. Kind of like looks weird over here, right? But this is the part that we're looking at. And basically it's saying x is equal to y, which means if x is basically the same as y, but it's not because 7 and 10, they're not equal, they're different. So that's why is equal will be false. That is not equal. Obviously, these are just a variable name. You can do anything you want. If you want a not equal to operator, then you use this exclamation mark. X not equal to y. What do you think the result of this expression would be? X is not equal to y. Is that statement true or false? True. So the value of the variable is not equal will be true. Sometimes we want to perform operators like greater than, less than, x greater than y. Okay, that's kind of simple. And less or equal, x less than. So this is simply saying less than y. But if you put an equal to sign over here, it will become x is less than equal to y. And you can do the same exact thing for the greater than. So if I copy this line over here, is greater or equal, I can say greater or equal. So we can do the same thing. All right. Then we have the logical operators. So let me go ahead and put a heading over here, I guess. Logical operators. All right. And these are comparison operators. So logical operators. So in logical operators, I'm going to go ahead and create some example. Has access equals to true and is admin equals to false. So two different variables, constant variables. Has access is true, Boolean. Is admin is false, again Boolean. Now I'm going to create another variable, can proceed, has access, and, so this is how you write and, is admin. So both of them have to be true, and this is the logical AND operator. Now, what do you think the result of, what will be the value of can proceed? This is saying has access has to be true, so this has to be true, and is admin has to be true. But it's not. See that? Has admin, has access is true, but is admin is false. In other words, both of them are not true, so the value of can proceed will be false. And I can always run the application, and you should be running it also, and you can see all the different values printed out. Okay. All right. Let's go ahead and do another one. Has privileges equals to has access or is admin. So this is the OR operator. And we can actually probably write it out over here, logical OR. What do you think the result will be? Has access or is admin. So one of them have to be true. Is one of them true? Well, looking at that over here, yes, one of them is actually true. The has access is true, so this will be true. Has privileges will be true, and you can actually run the app to find out. Right over here, you can see it is coming out to be true. All right. Let is guessed. What do you think the value of this will be? It's kind of like a combination of different things. Bang sign is admin. So is admin is false, right? False. But the bang sign before it makes false into true. It's kind of like inverts it. So if it's false, it's going to make it to true. So I'm going to write over here logical not operator, kind of like invert, right? So if I run this, is guess will be true. Then we have something called compound assignment operators. If I start with count equals to 5, I can actually add to the count in a different ways. Count, if to the count I want to add something, so count plus 3. So taking the value of the count, which is 5, I want to add 3 to it. So 5, 6, 7, 8, 5, 6, 7, 8. So it will be, count will be 8. But instead of doing this, I can also use kind of like a shortcut, plus equals to 3. Plus equal to 3 is the same thing as writing count equals to count plus 3, which we have already written before. And the good thing is that you can actually do that with any other operator also. Equals to 3, you can do that. Count is multiply equals to 3, so you can do all of these different variations if you want to. And finally, let's go ahead and talk about ternary operator, ternary conditional operator. Okay, so over here I'm going to create a variable called isNight equals to true. Okay, and now what I want to do is I want to say if basically isNight is true, then I want to basically set this message to good night. If it's isNight is false, I can set this message to good morning. So using the ternary operator, you can actually do that. isNight, if isNight is true, so isNight is already a Boolean true, right? So we don't really have to say isNight equal to true. Since isNight is already a Boolean value, we can simply say isNight. So if it's true, then this question mark is then, we will say over here good night, and then we say put a colon. This will be the else part. So good morning. All right. Now this will require a little bit more practice on your side because this ternary operator can be confusing sometimes, but usually I read it like this. If this is true, then, so question mark is kind of like then, do this, else do this. So that's how I read it. And this value isNight variable, or whatever you use over here, it should evaluate to either true or false. And that's the important part. All right. And that's it. So this will be, depending on now, isNight is true, right? So it's going to check, isNight true? Yes, it is true. Then it's going to say good night. So that's how it will work. So in this lecture, you learn about arithmetic operations, which are all of these, comparison operators, logical operators, as well as compound assignment operators and ternary operators. Now let's go ahead and talk about strings and strings interpolation. So we'll start with creating a string. So I'll create a string called language, and we will put our favorite language over here, which is Swift, of course, right? Okay, let's talk about concatenation. So concatenation basically means that you are concatenating, you are combining different strings together to form one long string. So I can actually say over here, hello, and the way that you concatenate string is by using the plus operator. And I can say language plus, and I can say exclamation mark, all right? Now keep in mind that strings are immutable. Immutable means that they cannot change, right? So what's going to happen is that when this string combines with this string, what is the value of language? Swift. So that's going to form another string. And that is going to combine with this string to form another string. All right. And the number of times you will concatenate, you will form another string, a brand new string, since strings are immutable. They cannot be changed. Now, in this case, it's okay. We're doing hello Swift because the language of Swift is, the value of language is Swift, and exclamation mark. But if you're doing this again and again, and you're combining a lot of different alphabets and letters in a loop and doing a lot of plus operators, then depending on how much you're doing, it can affect performance. Now, obviously, we're just starting out, so we're not getting into scenarios where it will affect performance, but keep that in mind, okay? All right, so another thing is appending. You can always also call language.append, and you can append something. So like I can say over here, programming. Now, if I go ahead and print out the value of language, what do you think it's going to say? It will say Swift programming. And you can see that there's no real gap between that, but we can always go and add a gap or a space so that it looks a little bit nicer. There we go. Now, sometimes we have a lot of different values, right? So I'm going to say over here, string interpolation. Sometimes we have a lot of values, like we have a name. I can say Alice. We have an age, which is whatever, 25. And we have a height, which is, let's say, 5.9. And if I want to combine all of this into some sort of a sentence, let's say introduction, right? I can actually use something like that. Because we already learned about concatenation. On line number 8, you can see concatenation. So I can say my name is, and I can say name, right? And I can go about and doing this by combining different strings with other strings together to form a much larger sentence. But there is a much better approach. This is called string interpolation. And again, string interpolation is available in pretty much most of the modern programming languages. So once you learn it over here, you will know everywhere. And the way that the string interpolation works is that you type in your string, my name is, and you use this particular syntax. It's a /, and then in the /, in the brackets, you write the name of the variable whose value will be inserted over here. So I'm saying over here name, and the value of name is Alice. So Alice is going to go over here. I am whatever age, years old. Okay. And I am value of height, and then you can complete the sentence. Feet tall. And you can see that it is a little bit nicer to read this. It's much easier to read this. We're not putting plus and all that stuff. My name is whatever the value of name is, Alice. I am whatever the value of age is, 25. And I am of height is 5.9. And internally, this will all convert to string value. Name is already of type string, but age is integer and height is double. But when you're putting it like this using string interpolation, they will automatically convert to string. And this looks much nicer now. Instead of adding like a plus, what we were doing over here, that will look messy. All right. So in this lecture, we learn about string manipulation and string interpolation. In this video, we'll be talking about conditional statements. So let's go ahead and write over here, conditional statements. And conditional statements, just like real life, you have conditions, right? If the door is open, then close it. If the switch is open, then close it. If the temperature is greater than 30, then write, it's a hot day. Else, if the temperature is less than 0, right? It's a cold day. So how can we do that, right? If I have a variable called temperature, and I'm going to use Celsius, but I think you can use just anything you want. So I'm in US, so the temperature is not in Celsius, it's in Fahrenheit. So I'm going to say, let's say 98 Fahrenheit, which is kind of hot. So if the temperature is greater than, and it's kind of like up to you what value that you want to put over there, but I would say anything over 79 or anything over 80, we can just say it's a hot day, depending on the humidity. So I can say it is a hot day. All right. Else, we can print it is not a hot day. So this is our condition. And these are used if and else blocks, or if and else. So if we start on line number 6, we can see temperature is assigned a value of 98. That's an integer. If the temperature is greater than 80, which it is because it's 98, 98 is greater than 80, then it's going to go execute this line. It is a hot day. If this statement is false, then it's going to go, it's not a hot day. If I run this, and you'll be able to see that it will print out it is a hot day. But if you reduce the temperature, let's say I do a 72, then it's going to say it's not a hot day. All right. Now, if you're using else, you have to use if with it. You can't really have only else. But if you're using if, you don't really need else. You can just say if temperature is greater than 80, then print it is a hot day. So you don't really need to, it's not a mandatory thing that you will need else. But if this condition is false and you want to do something, then you will just do this. It's kind of like you're saying, let's go and see if the Burger King is open, else we'll go to McDonald's. You know, these kind of conditions happen in life all the time. I'm going to buy a car, so if the color is white, I'll buy it, else I'll just buy the blue one. You know, these kind of conditions. Now, another thing about else is that this else is just going to get executed when this condition is false. But in else, you can also have other conditions. These are called else if. So else if temperature is greater than, and you can say over here something like that, 60, and temperature is less than equal to 70, then we can say it is a good day. All right. And we can put the else over here also, because if both of these conditions are false, so if this condition is false and if this condition is false, then we're just going to go ahead and execute the else over here. Okay. So let's go ahead and see what's going on over here. So these conditions are kind of like weird, right? Because over here it's saying if it's greater than 80, then we will do this, okay? But if it's between this and this, so let's see the temperature. If I say 68, and if I run this, it executes this one. See that? But if the temperature or if the condition does not meet this one and it does not meet this one, then it will automatically going to go over here. So what kind of a temperature should I put over here? So I'll say, let's say 42. And now you can see that it's just going to go else, because the temperature is not greater than 80 and the temperature is not even between 60 and 70. So that's why it simply goes to the else part. That's the only remaining part there is. Okay. So these are called the conditional statements. The other thing which you can do, which we have already learned, is ternary operator. So ternary conditional operator. And we can say is logged in equals to true. And let's say that we want to create or print a welcome message. So I can say if logged in, then we can say welcome back, else please log in. And we covered that in the previous lecture also. And the way to read this is, if this condition is true, then you do this, else we do this. Okay, so that's how you read it. And this is available in other languages also. So that's a good thing about learning a programming language is once you learn the language, any language that you want, then you can apply the same principles in other programming languages. So that's it. This is the conditional statements. All right. And next up, we're going to learn about the switch statements. Now let's go ahead and learn about switch statements. Now, switch statements, you will find them very similar to if and else or conditional statement. This is conditional statements, but switch statements are basically used in situations where you know the number of combinations. So it can be a compass. A compass can move north, or a compass can have like 4 directions, right? It can have north, south, east, and west. So you use switch statement in cases where you already know the cases. Let's go ahead and take a look at an example of day of the week. And I'm going to say day of the week is 3. So based on the day of the week, now we already know there are 7 days in a week. So that is our cases. We can have 7 different cases. It's never going to be like 8 or 9 days in a week. And what we can do is we can perform a switch on the day of the week, which is integer. And for every single item, we can say if case is 1, right? So over here we can say print Monday. And we can create these cases. Case 1 is Monday, case 2 is, Tuesday, and so on. So that is what it allows us to do. So this is just one of the ways. I mean, this is not the only way to be using switch, but this is one of the ways. So I'm going to say Monday. We have what? Monday, Tuesday, Wednesday. Case 4 can be, I guess you already know, Thursday. And then we can add case 5 and 6 and 7. So 6 and 7, and this is another thing. You can actually put 6 and 7 because if you want to print the weekend and the weekend applies to 6 and 7, which is Saturday and Sunday, then you can just create or put these cases separating by a comma. Now currently you can see that it's still not happy. It's saying switch must be exhaustive. What does that even mean, switch must be exhaustive? Well, what are the different things or variations that you can provide over here for the day of the week? Well, it really depends on what is the data type of day of the week. So day of the week is assigned the value of 3. So what's the actual data type for the variable day of the week? Integer. And integers can be more than 1, 2, 3, 4, 5, 6, 7. So for other values, we can actually say default. Default means if the day of the week is not 1, 2, 3, 4, 5, 6, 7. It's something else, maybe 12. And in those cases, we can say invalid day. Okay? And now you can see that it works correctly. So this is how you will create or use a switch statement. Now, the switch statement, one of the good things about switch statement is you can also use switch statement for pattern matching and using in ranges. So if I say a score of 55 or 85, I can perform a switch on the score. Now, score is integer in this case. But the good thing is that I can actually say if the score is from 0 to less than 60, where 60 is not included, then I can say fail. And similar to this, we can create more cases. So if the score is between 60 and less than 70, 70 not included, then we can say pass. So over here, we're doing pattern matching and also we are doing ranges. So that's pretty cool that you can actually do ranges, and I can actually copy some other stuff over here so that we cover all the different cases. If the case is from 70 to less than 80 over here means 80 is not included, so it's going to go from 70 to 79, 80 to 89, 90 to 100. I think this is going to be the whole thing. Keep in mind, in all of these cases, we're using this less than sign, right? So dot dot, only two dots, and then less than. That means that the range is going to start with 60, but it's not going to include 70. So it's going to go from 60 and 69. So that all of these numbers will be included, including 69. But when we use three dots, as you can see over here, 1, 2, 3, three dots, then it means that the range is going to start from 90 to 100. All right. So switch, very common in pretty much all the programming languages, and it is mainly used in cases where you have limited number of options. All right. Now, obviously, limited number of options, but over here we're using it in a different way. We do have more options, but we're only caring about these 7 options. And over here we do have limited options. The way that we're using is we have limited options. So from 0 to 59 is fail, 60 to 69 is pass, and so on. So this is how you can use switch statements in Swift language. In this video, we'll be talking about loops. So whenever you want to perform a task repeatedly or based on a certain condition a number of times, then you use loops. And the first one we're going to talk about is a for in loop. All right. So let's say that I have an array of fruits, and I will have apple, banana, and cherry. So it's a list, and it contains 3 elements: apple, banana, and cherry. And I want to go over this array and print it out. So how can I do that? Well, one way for me is to simply do this: fruits of 0, fruits of 1, and fruits of 2. So when we use an array, this item is on index number 0, index number 1, and index number 2. And that is why I'm providing over here index number 0, 1, and 2. All right. Now, if I run this, it is going to print apple, because apple is on index number 0. It's going to print banana, because banana is on index number 1. And cherry, because that is on index number 2. So it is going to print these things. But what about if I have an array of not 3 fruits, but 100 fruits? I mean, writing this kind of a code, that's going to take a lot of effort, right? So what can we do in this situation to make sure that we are not writing this kind of code to print like 100 times? And that is where the loops come in really handy. So instead of writing all of this code, I'm going to comment this. I can say for something in fruits, print something. Okay. Now, don't write this code like with dots, because it doesn't mean anything. So we're going to replace dots with a variable name, and you can choose any variable that you want. I'm simply going to say fruit. Okay, so how do we even come up with a name of a variable called fruit? Well, if I'm iterating, if I'm going over an array that contains fruits, apple, banana, cherry, what English word would you use to refer to these individual elements? I mean, it's a fruit, right? You're just going to say fruit. Now, you can use anything over here. Over here, you can use anything you want. I mean, I can say over here X, and I can do X. And it will work. I mean, if I go ahead and run this, you'll be able to see that it works correctly. But when you read this code, it kind of looks weird, right? It's not completely clear what this X actually means. So always try to come up with better words, better names for your variables. So when different person, maybe someone in your team is reading it, they can immediately know, oh, okay, this is what they actually meant. So since I'm iterating over, I'm going over an array of fruits, the individual item inside the array, I'm just going to say it's a fruit. All right. So this is how you can run the for in loop. The for in loop is going to run through all the items of the array, as you can see. So the good thing is that if I go ahead and add a different fruit over here, let's say I'll add a kiwi and I'll add an orange, orange, and I'll add a mango, then I don't really have to change this code that is iterating over the fruits array. I can simply run this code, and since this code simply go over all the elements or all the items inside the fruits array, it will get access to individual item. So first time it will be apple, then it will be banana, then it will be cherry, and so on till it reaches mango, the last one, and it will print it out. So the good thing about the for in loop is that it's going to start from the beginning and it's going to go all the way, it's going to end over here. And you can have 5 items in the array or 500 items. It's just going to go through all the items. Now, similar to another form of loop, or similar in that category, is a while loop. So let's say that if I create a counter and I assign it a value of 5. Now I can make a condition. I want to run a loop where this condition is going to be true. When the counter is greater or the counter is greater than 0, then run the loop. And I can go ahead and say over here, count down, and I can print the value using string interpolation that you learned earlier. But what do you think this loop, when is this loop going to end? Pause the video and try to find out when is this loop going to end. I'm not going to run this, and don't run this right now. I mean, you can run it, but it's just going to go forever. Why? Because the condition is never false. All right. So the condition counter is greater than 0 is always true because we never change the counter. It's always 5. So whenever you're creating a while loop, always make sure that you have a condition. In this case, now the condition can break, meaning the condition can turn to be true. Once you run the loop, it's going to be 5, right? 5 is greater than 0, yes, and this line is going to get executed. But then we subtract 1 from the counter. So now it's 4, and then 3, then 2, then 1, then 0, and on 0 it will break because 0 is not greater than 0. 0 is equal to 0, but not greater than. So at that time it will break. So if I run this loop, you can see that the output that it gives is 5, 4, 3, 2, 1. So that's while loop, very common in other languages also. Then we have repeat while. That's another type of loop. Let's say that if I have a variable called attempts and I have another variable called max attempts. So max attempts is a constant. You can't really change that. That's why we're defining it with the let keyword, and we're saying it's 3. And I can use repeat. So repeat what? Repeat attempt. And what we are going to do is we're going to say attempts plus 1. And then we're going to say attempts plus equals to 1. So repeat this thing. Repeat this while the condition is true, while the attempts is less than the max attempts. All right. So in this case, when we run this loop, if I go ahead and run this, you can see, oh, not attempt, it's going to be attempt. Okay. So when we run this loop, you can see the repeat part is going to run. attempt 1. All right, so attempts is 0 plus 1 is 1. And now we have attempted 1 time, so we increment it. And this loop is going to run while attempts is less than max attempts. So max attempts is 3. So that means when we go to a number attempts when it is 3, then the loop is going to break. All right. Now another thing about loops is the part for continue and break. So these are two different keywords which are also used in other programming languages. So let's say that if we have a condition like for number in, and this is another kind of loop. I mean, it's for in loop, but this loop is going through a range. And over here we're saying for, so it's kind of very similar to this one, the fruit one, remember? Fruit. So it's very similar to that one. And what we're saying is that for number, that's just a variable name, in this range. And since we're using 3 dots over here, this means 1 is included as well as 10 is included. So it's going to run from 1 to 10. Now, if I would have said something like this, then it would have run from 1 and not 10 included, just 10 minus 1. So 9, 1 till 9. But I want to include 10, so I can do something like this. Now you might be saying, why can't you just do it like this? Now it's going to run to 10. Yeah, sure, you can do that also. That's perfectly fine also. All right. I'm going to use this approach, a little bit more clear, 1 and 10 is included. Over here we can create a condition. If the number is equals to 3, then continue. Continue simply means that continue with the loop, basically skip this iteration. All right. And if the number is equals to 8, then we just get out of the loop. We basically we break out of the loop. All right. So if I go ahead and print the number value over here, we'll see that when we are break out of the loop, it means that the loop is just going to be, if it's like 8, so 9 and 10 will not be executed because of the break. When we say if number equal to 3, so 4, 5, 6, 7, they all will be executed. But since we're breaking over here at 8, this means the loop is going to be broken, meaning it's just going to skip. So this part, which is the body of the loop, if the number is 8, it's just going to skip to this one, the next line after the loop. So if I run this right now, you can see number 1, 2, 3, 4, when it reaches 8, this one number is equals to 8, it just breaks out. All right. So you learn about for in loop, while, repeat while, and also continue and break. So try to use these things in your application. Loops obviously are very, very important when you are working in any language, because whenever you have to do something repeatedly, then you use a loop for that. In this lecture, we'll be talking about functions in Swift language. And we'll take a look at the function syntax, parameters, and return values. Now, functions are first-class citizens, which means that you can pass them as parameters, return them from other functions, and also assign them to different variables. So let's go ahead and start with creating a simple function. Here's a function called greet. And when you call this function, it's simply going to print hello. The function starts with the keyword func. And if you see different languages like JavaScript, the JavaScript will start with function. I think Kotlin will start with fun. So they're all similar. This function does not really take any arguments. You can see that the bracket, the round bracket opens and closes. You can't really pass anything to it. How do you call this function? Well, you simply type the name of the function along with those brackets, the round brackets, and that's it. That's how you call the function. So what's going to happen is that once it reaches line number 8, it's going to see that, oh, you're trying to call the function greet. It's going to jump to the function greet and execute everything inside the function. Now there is only one line inside the function, which is print hello. So it's just going to call this, and hello will be printed on our output window. You can see that I'm running my Xcode playgrounds for the first time now since closing Xcode, so it took a while, but you can see that hello is printed. Now we can update this function to have multiple arguments. Let's say that if I wanted to pass in the name of the person as well as the age of the person. So how can I do that? So I can pass in name and I can pass in age. And I can also make it that it returns something. So this means that when I'm calling the function, I need to pass in two different parameters, the name, which is of type string, and age, which is of type integer. And this function will return something. Now there's a lot of errors we're getting right now. Let's go ahead and fix it one by one. The first one is saying that cannot convert expression of type void or expression of type empty to string. So basically what it is saying is that we indicated that we will be returning from this function a string value, but we're not really returning anything. And if we want to return something, we can actually use the return keyword. Now, since we only have one line of code inside the function, I can also leave it like this, and that will automatically return. Because it's only one line of code, right? We only have one single line in the function. Right now, just for clarity, I'm just going to add return. On line number 8, we have the greet function, which we're calling. But now, if you call the greet function again, you can see that those parameters show up. So you need to pass in the name and the age. So let's go ahead and pass in something. I'm going to say John Doe, age 56. Now, once we pass these values, the name is going to go into the name parameter, and whatever the value of the age is, that is going to go into the age. So basically, John Doe is going to go into the name parameter, and 56, which is the age, is going to go into age. So inside the function, we will have access to those two things. Now, I can use string interpolation to return a more personalized message. Hello, my name is, inject the name, and I am age years old. Nice, right? So whenever we call the function, we pass in the name, which is John Doe, and we pass in the age. Those two things go into the name and the age parameter, and then we can access it. We can build our message using string interpolation, and we can return it. Now, if I run this right now, you can see that this is what we get back. Hello, my name is John Doe and I'm 56 years old. So this function is actually returning you something, but we're not really capturing it. I can put greeting over here. What is it? What is the function returning? This, right? This part. This is a string. So when we call the greet function, it does something, it returns, and that return value is then placed into the greeting variable. And then we print out the greeting variable. So whatever is returned from the function, it goes on to the left of the equal to sign, and then we can simply print it. So if I run this right now, you can see that it's printed over here. My name is John Doe and I'm 56 years old. Now, one of the good things about functions is you can change it. Let's say if I have another greeting, greeting 1, greet Mary Doe. By the way, using numbers in variable names is not really a good idea, but I'm just explaining it to you, so that's why I'm using it over here. Okay. So you can see that we have used the same exact function greet, but this time we have passed different values. For the name, Instead of John Doe, we have passed Mary Doe. And for the age, instead of 56, we have passed 34. I mean, name is a string, so you can actually pass in anything you want. And age is an integer, so you can also pass anything you want. The main purpose of creating functions is that you can reuse those features in the future. And we have done that. Over here, we call the greet function, we pass in a different name and a different age, but we reuse the same function, but we ended up passing different name and a different age. All right, so that's the whole point of using functions. Now let's go ahead and create another function over here. I'm going to create a function called greet. And one of the things that you can do is you can add argument labels. So argument labels are nice if you want to, when the caller is calling the function, they can provide some more meaningful arguments. So let's say that if I'm saying person name from country string, and this is going to return string. So I'm going to go ahead and return something over here. Let's say hello, and whatever the name of the person is, greetings from their country. So just going to inject the country over here. All right. Now I can go ahead and say greeting to greet, and I can pass in. You can see that the label that we added, the argument labels, that kind of shows up. The person shows up over here, and we have the from shows up over here. So these are just the labels. The actual value that you're passing is going to be stored in name and country. So I can go ahead and call this person, okay, whatever the person is, Alice, from USA. And then we can print it out. Greeting to. And there we go. Hello, Alice. Greetings from USA. Another thing that you can do is provide default values for your parameters. Those are known as parameters defaults. Now, if the person does not provide with the name of the country, we want a default value to be USA. All right. So if I remove this USA when I'm calling the function, you can see I'm not really passing USA, or I'm not passing the country over here, right? So what will be the default value of the country argument over here? USA. And we can run this to see. See that? It's still USA. But maybe you do decide that, oh, I need to pass in something. So I'll say country, and you can say Canada. So this time you are, or not country, but from, because we're using the labels. So in this case, we are passing Canada. So we are not going to be using the default values, because default is only going to be used if you don't pass it. But now you are passing these values, so you're going to use Canada. So if I run this, you can see Canada. All right. So these are the basics of a function. Definitely check out Swift language documentation. Obviously, there are more ways to call the function, more ways to create the function, more ways to return from a function. But this will at least get you started if you have never used functions before in Swift language. In this video, we'll be talking about closures. Now, a closure is a self-contained block of functionality that can be passed around and used in your code, in your applications. Now, closure can also capture and store references to variables and constants from the surrounding context. Let's go ahead and take a look at how we can create a closure for an add function, a function that adds two values. Let add. So you define it just like you define a variable. But in this case, the add is a closure, which means that it's basically a function, And this function takes 2 arguments. Both of them will be integer, and you're going to return an integer. See that? I mean, it looks kind of weird, right? Because when you're declaring something like a variable number equals to 100, it kind of is simple as that. But keep in mind that closures are actually functions. So, and this function takes 2 arguments, integer, integer, and returns integer. It's kind of like a function if you had to build something like this, A, B. See that? It kind of matches what you're doing, right? Now, I'm not going to write this because we are learning about closures. And then you can define the actual, the body of this particular closure. And in the body, we can say, well, we're going to get A, which is integer, and B, which is also integer, and then we can return something. Return A plus B. So this is one of the most simplest closures you can write. I know it kind of looks weird, but keep in mind that this part is more of a definition of the closure, at least this part. And this is the actual body of the closure. Now, when you define this closure, the question is, well, how do you use it? Well, you use it just like normally you would use any function. So this is the closure, and I can pass 2 different values over here, 5, 3. It's going to give me some sort of a result, and I can then finally print out the result. Let's go ahead and run this, and you can see I print out 8. Now, this is all fine, but we can actually write a different closure and make it a little bit more easier to return. So let's go ahead and create a closure, multiply. Again, multiply closure, basically a function, will take 2 values as input, and it's going to return some sort of output. What will be the body of this? Now, we're trying to use a more concise way to create the body. The first argument that you're going to get and the second argument, you can extract out these arguments or access these arguments by the syntax $0 and $1. So $0 will be this argument, and $1 would be this argument. Now keep in mind that your closure, we are indicating that it is going to return an integer. I might say, hold on a second, this is not returning anything. Well, hold that thought. If I have to create a function called multiply, just call it mul, A and B, and it is going to return integer, I can go ahead and do A multiplied by B, right? This is perfectly fine, right? But I can also remove the return over here, and that will still work. And we covered this in the last video, that why this will work. This will work because the body of this function mul only contains one single line. So whatever the result of this multiplication is, it will automatically be returned. A lot of other languages does the same thing. I think Ruby also is the same way, that if you have a single line of code in a function, then whatever that line produces is automatically returned. So we're using the same concept over here. That's why we don't really have a return. Whatever $0, $1, when you multiply them together, whatever is returned, whatever it produces is automatically returned. Okay? And how do we use it? Well, same way. We'll say multiply 4 and 2. Whatever it returns, we're just going to print it out. So 4 multiplied by 2 should be 8, and we get 8 again. I mean, I guess I can multiply with 4 multiplied by 4 to be 16. There we go. All right. Now, there's another concept in closures, which is trailing closure syntax. All right. Trailing closure syntax basically means that either you have a function that has one single argument, well, not one single argument that is a closure, or two arguments, but the last argument is closure. Okay, let me give you an example. So if I have a function over here, perform action, and we learn about that how we can create closures, define closure body, but you can even pass closures in a function. So if I were passing an integer, I would declare it like this, right? But if I want to pass a closure, I can define the closure like this. I mean, this basically means that you're creating a closure which doesn't really take any arguments and does not really return a value. And whatever you pass in, we just execute that. Keep in mind that action is now not an integer, but a function that takes no arguments and it doesn't return anything. So how do we call this? Perform action. Now there are multiple ways of calling it. You can see that I can fill out these details. And this is called the trailing closure. Trailing closure basically means that since this is the only parameter or a parameter to the perform action function, we don't have to even pass in this label of action. I guess we can if you want. I mean, you can do it something like this. You know, it doesn't really something like that. That's fine. And I can say perform action called or something. All right. So, but you don't need this. You don't need this action label over here, because since the only argument we have over here is the closure itself, you can use, and this is called the trailing closure syntax. Perform action called. So this part is known as trailing closure syntax, which kind of looks weird, but it's kind of like a shortcut to write these things. All right. Now, closures can also capture the values. So I can say capturing values in closures. So let's go ahead and define a closure. We'll call it make incrementer. All right. And we will have a single argument. We're going to pass increment amount, but that will be integer. Okay, and what it will return, because you can also return closures, right? What it will return will be a closure which doesn't take anything, but it returns integer. I know it's getting a little complicated, right? But stay with me over here. So we have a function called make incrementer. It takes a single argument called increment amount, which is just an integer, but the function itself, the make incrementer, returns a closure. That closure is basically a function that doesn't take any argument, and that function returns an integer. Now, if I go ahead and create total equals to 0, and I have to return something, right? So I'm going to return over here total plus equals to increment amount, and then I can return the total. So that is the stuff that we are returning over here. All right, so this is the closure. This is the closure. See that? It's not really taking any argument. So that's that part. And we are returning an integer from the closure, which is this part. Now the question is, well, how do we use it? Well, I can say make incrementer. I can pass in 2. Increment by 2. And I can also call this again. So I can say increment by 2, just like a function. And I can call it multiple times, increment by 2, and so on. So let's see. If I run this right now, you can see that since the values are actually captured, we are incrementing by 2, 2, 4, and so on. All right, so when you create closures, you can also capture the values in the closures. So this is kind of like cool if you are trying to build some incrementers or trying to retain those values. So in this lecture, you learn a little bit about closures. hopefully you'll be able to, practice this more. And closures are everywhere. If you're trying to do anything with async and await, you're using closures. If you're using some third-party libraries for database access, they have also closures. So closures are very widely used in Swift language. All right. So hopefully you have enjoyed it. Thank you. Now let's go ahead and talk about nil goal-setting operator in Swift language. Now sometimes we are using optionals, right? I mean, we can have a name that is optional. Not like that, like this. So the optional simply means that it can have a value, but it can also not have a value. Now, if I simply go ahead and print out the value of name, and we're using playgrounds, that's the best way to check out your code in Swift. The couple of different things will happen. You will see that since I'm using let, it's not really allowing me to, print anything because I haven't really assigned it. What about if I say var over here? Now, if I say var, it does actually print out nil. So that's one of the things that you need to remember, that if you say let over here, you need to make sure that you assign it some sort of a value. So let's go ahead and assign some value. Now, if I print this value, it doesn't print out Muhammad Azam, it prints out optional of Muhammad Azam. And the reason is that this particular question mark is wrapping Muhammad Azam, or whatever name that you provide, into optional, which optional is a struct. Or sorry, optional is an enum. Okay, you can actually type in optional, and if you say option click, you can actually see over here it's an enum. So now the question is, well, how do we unwrap it? There are many different ways of unwrapping it, but one of the shortcuts is to use nil goal-setting operator, which basically means that you can use these double question marks, and you can provide that if the name is nil, what value should I use? So I will simply say guessed. So this means that if the value of name is nil, we're going to choose the right one, which is on the right hand side, which is guessed. So let me go ahead and change this to var and remove that. So now you can see that the name value we have in assigned, so name will be nil, and this double question mark is basically saying that, oh, if the name is nil, then use this value. Okay. So if I do that, it's going to print out guessed. What about if we change the order? Or does it even matter if we change the order? All right. This is kind of interesting, right? If you change the order, then it is going to return this part as optional. So it's always very important that the thing that you're unwrapping will be on the left-hand side, which you can see right here. So this part will now get to be unwrapped. If it's unwrapped, and if it does have a value, then it will take this value. Right now, it doesn't have the value. That's because we are not really providing anything, but let's go ahead and provide a value. So I'm just going to go ahead and say Muhammad Azam. So what it's going to do is, since name is no longer optional, no longer empty or optional, it's going to unwrap it and just give me Muhammad Azam. All right. So that's a very important operator, nil goal-setting operator, that you can use, and it will provide you a lot of cool benefits, that a shortcut that you can write. So hope you have enjoyed it. Now let's go ahead and talk about optional chaining in Swift language. So optional chaining in Swift language is a feature that allows you to safely access the properties and methods or subscripts of optional types. So what do we mean by that? let's go ahead and take a look at an example. I'm going to go ahead and create a person class. Now this person class can have a couple of different properties like name and maybe even age. Now age over here is using the optional type. This means that we can have age, but we can also have nil as age. And since we have created a class, we do have to provide the initializer for it. So let's go ahead and provide initializer. Self.name equals to name, self.age equals to age. Okay, so this is all good. Now, if I want to create a person, how would I do that? Well, let person equals to person, passing in some sort of a name. So I can go ahead and probably I can simply pass in my name, and I can pass in age. Now, age I can simply pass in nil because I don't have the age right now. If I go ahead and access person dot age, then you will see that it simply prints out the optional of age. Oh, sorry, nil, because that's what we provided it. All right. Now, in this case, we can also make the person to be optional. Now, if the person itself is optional and you try to access the age, look what happened, person.age, and it puts a optional question mark right next to the person. So what is this saying? This is saying that only access the age property if the person does have a value. Now, if I go ahead and simply print this out, you will see that it's basically saying that it can't really do anything right now. It simply prints out to be nil, right? So it doesn't really blow up on anything. Well, it can't right now because the person does have something. So it's checking that if the person is not nil, because the person can itself be nil, and if it's not nil, then go ahead and give me the age. But even if you do have an age, so let's say that if I provide the age, you will see that you are going to get age as optional. So what we need to do at this point is to unwrap it. So if let age equals to person, which is already optional, dot age. And now once we get that, we can simply go ahead and print it out. So now we'll be able to get the actual age. Now how will that work with the last thing that we were discussing, which is a nil colon operator? Can we do something like this? Person dot age, and if the age is nothing, we'll say whatever, 18. We have to return something, right? And then we can simply print out the age. And you can see that you can use this approach also with nil colon operator. Now, this concept can be applied to much deeper levels also. Okay, so let's take a look at another example. I'm going to go ahead and probably comment this out. And what I want to do is I also want to create an address. An address can have a street. So all of these things are fine, street, and we can even say city. And we can use street, which is string, city, which is also string, and we can say street equals to street, and city equals to city. Okay, so at this point it's all fine, but now we're saying that the person can also have the address. So, and some people may have an address, but some people may not have an address. So we have to make sure that the address is optional. This also means that we need to pass in the address, which is optional. Now I can provide a nil value over here. So this means that if you don't pass, it will automatically pass nil. Self.address equals to address. Okay. Now we can create a person. I think the same person that we created earlier on. Okay. And if I want to access a city, I can say person, which is optional, dot address dot city. But you can see that there are multiple over here. We're using multiple optional unwrapping chaining going on, which is basically saying that, oh, if the person is not nil, then go ahead into the address. If address is not nil, then go ahead and give me the city. Now, if you do get the city, you are not going to get a, we'll see. If I say city, it says string, but let's say, what do we even get over here? I mean, the city, currently we don't even have the city, right? So if I simply say city over here, I'm not really going to get anything. I'm just going to get probably nil or something. So let's go ahead and run this. Nil. We don't have the city. Okay, so now we can go ahead and try to pass in the address. So I'm going to pass in the city, which is 1200 Richmond, that's a street, and let's just call it Houston. Now we do have a city, but if I print it out, it's going to give me optional of city because you're going through the optionals. And that's the important part to remember over here is that you have to, this city that you got, you have to unwrap it. So if let, and then we can print out the city, which hopefully will be unwrapped at this point. Not else, sorry. Just if let is fine. And now we can say Houston. So optional unwrapping, definitely you should be using optional unwrapping. This is also known as safe unwrapping because you're only unwrapping when you know that that particular thing is not nil. So that is the optional chaining in Swift language. All right, everyone, let's talk about forced unwrapping. Now, forced unwrapping is not really considered a good practice when you are programming in Swift language. And the reason is actually pretty simple. Let's go ahead and take a look at an example. So if I go ahead and create a name over here, a name variable, and I don't really assign any value, or I can assign a value if I want to, but if I don't assign the value over here, the string value by default will be nil, right? Or even int, I guess, in this case, because it's optional. If I go ahead and try to print out or force unwrap it, I mean, if I print it out right now over here, it will simply say nil. But if I try to force unwrap it, then it's going to be a problem, right? Because you can't really force unwrap it. It's going to just crash. Force unwrapping basically means that you're trying to get a value out of the optional, but it doesn't really have the value because you've never really assigned it. Now, what about if I do assign a value? Can I then force unwrap it? Yes, in those cases, you can force unwrap it, as you can see, and it will unwrap and give you the value. Now, you have to be very careful whenever you're doing force unwrapping, because whenever you do force unwrapping and you don't have the value, like it's nil or something, then it is going to blow up. So you have to be careful of understanding that the value will have something in there. So another example that most people do is when they are creating a URL. So let's say that they have a certain URL and they can say HTTPS and their server URL, whatever the URL is, server.com, whatever. And this is going to return you, if you print out the URL, as optional. And they can completely unwrap it. Now, if they unwrap it over here, they have to be 100% sure that the URL will have a value. Now, in this case, the URL does have a value. Now, this URL may be, what about if this URL is incorrect or something? What about if I say something like this? Will it still give me that particular thing? If I go ahead and print out the URL, what will happen? Is it going to blow up or is it going to just give me DDD? And it does give me like that particular thing, all right? So, and if I put it something else, then I'll get that URL. So what about if I don't have the URL? What about if I have it something like this? And there we go. So again, you're trying to force unwrap it over here, and you didn't really provide the URL. So it's going to tell you that there is some problem and you need to make sure that you provide the correct URL. All right. And in those cases, you can definitely see that it's going to blow up as it is blowing up right now. It's telling you that you can't do that because you didn't really provide a string. Now, if I provide some sort of a string over here, then it's all okay. It's like, okay, that's fine. You can use it. So that's why it's really important to know, to find out that the thing that you're trying to unwrap, it does exist. Because if it doesn't exist, then it's going to just blow up. Your whole app can crash at that point. All right. So even if you're using force unwrapping, don't just try to use it like every place. If you have to use it somewhere, then obviously make sure that the thing that you are unwrapping, the value for that thing does exist. All right. So even though this is a operator in Swift that you can use, you have to be very careful when you are using force unwrapping. And a lot of different places, if you're using SwiftUI and you're trying to force unwrap something, your previews are not going to work. It's going to just blow up because, it depends on the value, and now you're force unwrapping it. So it's going to crash. The same error, the nil error is going to happen, and your previews are also not going to work. So make sure that if you are using this technique, first of all, don't use it unless you have the last resort. But if you are using it, try to make sure that the value that you're trying to unwrap, or the thing that you're trying to unwrap, contains a value. So that is the force unwrapping. Let's talk about implicitly unwrapped optionals. And you can see that we are not really using playgrounds over here because I want to give you a very practical example that you also have been doing if you have been doing UI kit development. Remember, in UI kit, you can create an IB outlet, and that IB outlet can represent some sort of a label. Let's say a message label. And we can use UI label. You can see right over here, we are performing the implicitly unwrapped optional, which basically means that these are automatically unwrapped when they are accessed without requiring the unwrapping from the, some other force unwrapping operator. Now, you have to be very careful. This means that anytime you're going to be using message label, this does have a value. This should have a value. So it should be hooked up onto the storyboard. If it's not, then you are going to face problems. So if I go ahead and say, and I haven't really hooked up anything, but if I happen to go ahead and assign some value to the text, let's say hello world, well, we're going to get a problem over here because the message label is implicitly unwrapped UI label, but it's not going to produce anything because it's not hooked up correctly. So if I go ahead and run right now, you will see that it's just going to fail because we forgot to connect the IB outlet correctly. All right. So when it runs, you'll see that this part is going to give you some issues. And there we go. Unexpectedly found nil while implicitly unwrapping an optional. So that's a problem with these things, that you have to be sure that when you access them, they're not nil. Now, a simple solution would be to simply go to your interface builder or your storyboard, try to find that particular label, which we don't even have. So make sure that you add a label like this one. If you're using storyboards, you can put it anywhere you want. And then we have to make sure that we are connecting it with the IB outlet correctly. So message label and connected. Okay, so that's the important part with when you're using implicitly unwrap optional, that they must have a value or else they will not work. Now in these situations, when you actually are connecting IB outlets, it's perfectly fine to use the implicitly unwrap optionals, because if you don't have these, then it means that your UI is on user interface is not even working and it's not really hooked up correctly. So if it fails, it's fine because now you can go and fix it. Okay, so it's going to be a runtime error, and you are going to find that out when you are running the app. I mean, the UI is not even going to load correctly. Okay, so once again, when you're using implicitly unwrap optionals, these are automatically unwrapped when they are accessed. And when they are accessed and they're automatically unwrapped, you have to make sure that they do have a value. If they don't have a value, then obviously it's going to be a problem. Now, if I run the app right now and I assign it hello world, I don't think I have added some constraints, but you can see it does print out hello world. Okay, so these are the implicitly unwrap optionals in Swift language. Let's talk about another way where you can work on the optional values in Swift. And this is one of those ways that most people actually don't know about. This is the optional mapping and flat mapping. So what exactly is optional mapping? Let's take a look at an example. Now, if I have my name over here, and I'll assign my name over here, I can actually perform a map operation on it. Now, when we talk about the map operation, whenever we hear the term map, we're like, oh, we can perform this on an array. But apart from performing these things on an array, this is known as optional mapping, which means that you can map it and you can transform this to something. All right. So if you want to do something with it, let's say that if I want to transform it to name dot count. Okay. So what exactly is this going to return? Let's say result. If I go ahead and print this out, okay, so a couple of different things going on over here is what we are doing is we kind of completely ignore, oh, it should be $0, sorry, $0 dot count, because we're trying to access the element itself. Now, if I do that, you can see that it's going to give us kind of like optional of 13. Okay. So what name is over here doing is that inside this map, you have access to the unwrapped version. So because if I type over here, you'll see $0 dot, it's not telling us that the $0 or the first argument is optional of string. It has already unwrapped it and it's giving you access to that string. So that is the optional mapping. Now you can use this in SwiftUI also. Sometimes people like to do whatever name.map, and then once they get the unwrapped version of it, which is $0 right now over here, then they use that to print it on the label or do something else. Okay. Now, similar to the optional mapping, there is also something called the flat mapping. Okay, so flat mapping is very, very similar to optional mapping, but it is used when the transformation returns an optional value. So the transformation itself returns an optional value. So in this case, even if we do perform the flat map result, let's say flat map result, you'll see that it's going to get kind of like the same result in this case. And now if I say $sign of this, what we can do is change this number. Instead of this, let's go ahead and say we're going to do on 10. Okay. So inside over here, $0, we get the actual integer. Let's go ahead and do it again. Flat map. Oops. $0. And you can see that we're getting all this stuff, but what exactly is this $0? It's string. Okay. And now we can actually perform whatever we want to do. And we can print out flat map result. Now it's going to be kind of like the same thing that we did over there. So a couple of different things you can see over here. It's basically telling you that you cannot convert this because the argument itself that you're trying to do is not even optional. So this is not optional. So let's go ahead and make it optional. number 10, and we will make sure that this is a optional thing, and then we can perform it on the number itself. Okay, and there we go. So it produces kind of like the same thing. Now, if inside we try to access it, let's see if it actually shows us what it is. It's a string, all right, because we have the value as a string. So the main difference, in other words, between the map and the flat map is the flat map mapping flattens the resultant optional value so that the result is a single optional value, okay, rather than the optional within an optional. Most of the time, I think you will be using the map, unless you want to flatten out something, then you can use a flat map. But they're very, very similar. The only thing is that the flat map will flatten out. And especially this can be useful if you're working with an array of something, array of arrays, which you want to just flatten it out to a single array. So in those cases, it can be really very handy. Now let's go ahead and talk about associated types in Swift language. Consider an example that I have a couple of different structs. So I have a codable struct over here, which is title, and I have another struct for a user, which is also codable. Okay, that's fine. And I will also have a web service protocol. So I'm just going to go ahead and create a web service protocol. This will only be applied to the classes. And it has a particular function, let's say get all. You will pass in the URL of the service, and in the completion, we are going to say result of, well, of something, right? And the error. Now the problem over here is that result of what? Because sometimes we want this result type to be of a movie, but the other time we want the result to be of type user. But how can we even do that? This is where the associated types come into play. So we can simply create an associated type and call it model. We can pass in over here a model. Now associated types are created in the protocol, so that's why you can see that I am declaring it inside the protocol. Now, whoever is using this protocol can create that particular associated type. So this means that I can go ahead and create a movie service, which is a web service protocol. Web service, I'm not sure why it's not coming up over here. Let's go ahead and see. Protocol, I think it should come up over here. It is a class. Okay, so we have the web service protocol over here, and we need to tell the movie service that what will be the model type. So now the responsibility is on the movie service to say that what will be the type alias. So I can go ahead and say type alias will be the movie. And now I can go ahead and implement, that particular type over here. So model is movie, and I think movie is something that we have already declared. And now I can simply change this to, it will be movie, all right, or whatever the model is. I guess in this case, the model will be movie, and error. Okay, but in this case, we might be interested in returning an array or something, so that is also fine. Okay, and we are going to see that if I'm doing it correctly, let's go ahead and make sure that the result is wrapped up correctly. There we go. And now I can go ahead and try to implement these things. Okay. Now, a couple of issues over here. We are saying that we are going to be returning get all, right? So it has to be an array of models. So let's go ahead and do that. Also change it to array of model. And apart from that, let's go ahead and compile it over here. I don't think it likes the class part, so let's remove that part. Okay, so it's saying the generic type specialized with too few parameters got one but expected to. I think we forgot the error. So this is common problem that sometimes you just place the caret at the wrong place. There we go. So what has happened is now we have this web service protocol. It has the associated type. It has the get all, which is a function, but the caller can change the associated type. Caller can say that, oh, the model that is going to be used will be the movie or the model will be user. So if I want to create a user service, I can actually do that. I can say user service, which will be web service protocol. But in this case, the type alias for the model will be different. It will be user. And now I can copy the same function and apply it over here also with the model, which in this case will be user. So this is the associated type. Associated type allows you to set the type in the protocol. That type can be set from the concrete classes like the movie service or the user service. Okay, so this is the important part, and this is the associated type in the Swift language. Now let's go ahead and talk about generic functions. But before we talk about generic functions, let's go ahead and write a function that is going to give us the first element when you pass an array. So if I have an array over here, it's simply going to return us the first element. If it doesn't exist, it will return nil. So how do we do it? Well, we simply call array, the thing that you actually passed in, dot first. Okay, so that is going to give you the first element. Now, if I go ahead and run this application, and if I have an array, and if I want to pass it, let's see what happens. So I have names, and I have a couple of different names, Alex, John Doe, and I will have Stephen. If I want to use this, I can call first element. I can simply pass in names, and it's going to return me optional of that particular first element, which you can see is coming out to be Alex. Now you have already learned how to unwrap it, right? So this is going to be your test. If let first name equals to first element, passing in the names, and now we can go ahead and get the first name. There we go. Great. But this only works with string arrays because it actually takes in a string. If I want to do the same operation, but I want to do it on numbers, I will have to create another function. Well, you don't, because you can use generics. In generics, you will simply pass in the type. The T over here is a type. This is basically saying that we don't know the type. It can be string, but it can be anything else also. So T, I mean, you don't have to say T, you can say K, you can say T, you can say type, you can say type like this, but usually people use T, okay? So this is a type that will be represented by either the thing that is being returned, the return value, or the type that we are taking in. So we can replace the string with T and the string with T. This means that this particular function is now going to work on any kind of type, not only string. What is the type? Well, we don't know, because when you call this function, then you're going to supply the type. So let's go ahead and see what happens now. If I simply go ahead and uncomment this code, and I run this, I still get Alex, which is great. But what about if I have an array of numbers? So if I say numbers, and I have, different numbers over here, the great thing is that now I can actually call that on the number. So number equals to first element and array of T, meaning any type that you can pass, and I can pass in the numbers, and then I can go ahead and print out the number. So it's great because now we didn't have to create separate functions. We only had to create a single function which is based on that you will be providing generic types to it. Generic type simply means that we don't know the type. It can be anything. It can be string, it can be Boolean, it can be, double, it can be an object, it can be anything. And this gives us more of a basically flexibility, so that we didn't have to create one for the string and one for the numbers. We just created one, which is called first element, and this is just going to return us the first element, and that's it. So this is the generic functions in Swift language. Generics are not only applied to the functions, but you can use generics in structs and classes also. Let's go ahead and take a look at one example. If I want to create a struct called pair, which can take two different generics, right? T and K. This means that the T and the K is a generic type. We don't know what type is it, but we know that it is some type. We will put these values into the variables first and second. And now we can go ahead and create this pair. So pair, and passing in the first, which will be hello. Now for the second, we can pass in world, but we don't really have to pass in world because it is a generic type, so it will be able to evaluate whatever type that we're performing. So instead of hello and world, I can say hello and 99, and that would be fine too. So in this case, the first type, this one T, will become string, and the second type, 99, will become int. And that is how you can use generics in structs also. What about classes? You can definitely also use classes. Let's say that if I'm building a class called stack. Now the good thing about this particular class is that we don't know what kind of items you're going to be putting in the stack because it's generic. So it's not string, it's not int, it's generic items. And I can say items T of an array. This means that we will have an array of items, but we don't know the type. And we can also create a push function where we can actually push the item. Items.append the item. And in a stack, you also have pop, right? So we're going to do pop, and it's going to simply return the items.poplast. And there we go. We have used class, and this class does have access to generics. It's a generic stack class. Now, if I want to use it, I can easily use it by saying stack equals to stack of int. So this means that now we are creating a stack, and this particular stack contains int. I can pass in whatever, 4. I can pass other values to it also. There we go. And I can call stack.pop, which is going to return me the value, which is the optional. But this is the important part. This allows our stack to be generic type. Because now, later on, if I want to, I can create another stack using the same feature, but this time saying, well, this will be a stack of strings and not a stack of ints. And now I can go ahead and say another stack dot push, and I can push whatever I want. So I can push John. I can say another stack dot push and Mary, and so on. So that's the great thing about generics, is that even though you have a struct or you have a class, you can still use generics to accommodate your needs. Now let's go ahead and take an example of putting constraints on generic types. Let's say that if I'm creating a function called encode, okay, and it does take a generic because we want to be able to encode anything and whatever the item that you want to encode. After over here, we can simply use the JSON encoder and we can perform encoding by passing in the item. Now, if we use this code, your JSON encoder is going to complain. And the reason it is complaining is that it is saying that you have declared a type over here, but this particular type does not conform to encodable, which basically means that you can just send anything to the encode function and we may not be able to decode it. Like if I go ahead and create a customer struct over here, and if I go and create an instance of the customer, I will be able to pass in that customer to the encode, and that is wrong because the JSON encoder will not be able to encode it because the customer struct does not conform to encodable. So let's go ahead and do that. Let's go ahead and make sure that this conforms to encodable. But just by customer conforming to encodable doesn't really make this work. And the reason it doesn't really make this work is that the type does not really have any constraints on it. So the type is saying that, yeah, you can pass in anything you want. And that's wrong. We need to tell the type that, hey, only you can pass in stuff that is encodable. And now I can go ahead and say try, and this function can throw an error and all that stuff. Okay? So this is how you can put constraints when you are using the generics. Very, very interesting. And now if you have something, let's say if you create another struct, which is user info, which also contains name, it doesn't really matter. You create a user info object, user info, you pass in the name, whatever the name is, Stephen Smith. If you try to call encode and passing the user info with even the try block, it's not really going to work because the user info is not conforming to encodable. And our over here that we constrained is limiting it to use that. So that is always good if you are creating a function that where you take in a generic, but that generic will be must conform to something, then these constraints are very helpful. So you know that the data that you're getting inside the function is already validated, and now you can perform different actions on it. Okay, so that's the main use of constraints in generic in Swift language. Now we are going to learn about protocol inheritance in Swift language. Let's go ahead and create a very simple protocol called Animal. And that will consist of a property called name, which have a getter, and also a function, which will be make sound. This means that if you are conforming to animal protocol, you must provide a getter for a name and also implementation for the make sound. But guess what? There's another protocol because animals can also fly. So this protocol is called can fly, and it's going to be conforming to the animal protocol. This means that if you conform to the can fly protocol, then you have to define name, make sound, and also anything that the can fly protocol is saying. So I'm just going to go ahead and say fly. Okay. Now if I go ahead and create a bird and conform to can fly, and if I try to run this application, you can see that it is telling us that the bird class does not conform to the protocol animal. So if I go ahead and fix this, you can see that I have to implement the fly function. I have to implement the var name string, meaning the property, and the make sound. In other words, since the bird is conforming to can fly, I need to implement everything in the can fly and I also have to implement everything in the animal protocol. Now, what happens if I go and create a fly function in the animal? All right. So now what will happen? Let's go ahead and first fix this part. Let's go ahead and remove all of this and see what happens. You can see that when you do a fly function over here, first of all, it's telling you don't have any initializer. So let's go ahead and fix that part. So I guess we already have the name, and the only thing we need is name for the getter, but we can initialize it. We can allow the user to pass in the name for a bird. And now I can say name. Okay. But what about the fly function? We have a fly function and we have a make sound function. Oops, not sure what's going on over here. There we go. Okay, so we have the fly function, we have the make sound function. The can fly contains the fly function, but the animal also contains this particular function. All right, so is a bird going to be conforming to the can fly function, or is a bird going to be conforming to the animal fly function? It doesn't really matter in the end. The bird will be conforming to the can fly because it's much closer. Okay, it's a direct inheritance that you're doing. And that's pretty much it. That is the protocol inheritance in Swift language, which simply means that you can have multiple protocols inheriting other protocols. And if you start using can fly, then you also have to conform to all the different protocols that this is conforming to. So in other words, if I go ahead and create a protocol, for some reason, I create a robot, and I would say start, and I can go ahead and say robot over here, then again, the bird is in trouble because even though the bird does conform to the animal, it does not conform to robot. So we need to implement start. So there we go. So now we can do both of them. So this is those situations you have to really think about, that if the protocol inheritance is going to make any sense for you or not. Now let's go ahead and talk about protocol composition. Now, if you have been programming with Swift language, you may have already seen protocol composition where different protocols kind of compose, join together to form one. If you look at the codable protocol, this is a very interesting one. Let me go ahead and write it again so you can see that in the documentation. Right over here, you can see that the codable protocol is basically a composition of decodable and encodable. This means that if you say that you're going to be accepting a particular object that is going to be accepting, or a function that is only going to be accepting a codable thing, then that means that will be a code decodable and encodable. Okay? Let's go ahead and take a look at that particular example. What about if I create a function and I say decode? And you're going to send me some item to decode, and I'm just going to say that, well, that particular item will be conforming to codable. And that's it. And then I can decode it, or I can perform some action. Let's go ahead and use encode, I guess. That's much easier, because now we can call JSON encoder.encode, and then we can encode the value, which is item. Make sure that we use try. I'm just going to use try optional in this case. This means that the encode function you can call and pass in the item. That particular item must be conforming to codable. So what does that mean, conforming to codable? If I create a struct over here, customer, and it is only decodable with a particular name, can I go ahead and create an instance of this customer and call the encode function? Will that be okay? Well, not really. Because even though our customer is conforming to decodable, it is not conforming to encodable. And that is a requirement for codable. If I look over here, you can see the documentation. Codable is simply a type alias, and it's actually a combination of decodable and encodable. So both will have to satisfy. In order for doing that, we can go ahead and say encodable and decodable. Well, that's a little bit interesting. And it works because now you're saying that the customer is conforming to encodable and decodable. But why go to the effort of this much when you can simply say codable, which is already a combination or a composition of decodable and encodable. So it's already present for you or for your usage. So just like the codable class over here, or the codable protocol is available to you, and a codable protocol is a composition of encodable and decodable, you can create your own things also. So a good example will be if I create a can fly protocol, and that will have a single function fly. I will also create can swim, which will have swim function. Now, maybe I want to create some sort of a function which is called perform action on a particular item, and I want to make sure that that particular item, animal, whatever you want to say, is conforming to can fly and can swim. So that particular item that can fly as well as swim. Okay, and then we can construct the body. So the only things we can send to this function as an item will be something that can fly and can also swim. So what can that be? Well, we can create a duck and conform to can fly and also can swim. You can actually do that also. That's perfectly fine. Okay, using the comma. But we still need to implement the functions, right? Oh, can fly and can swim, sorry. So if the duck is conforming to can fly and can swim, we must also implement the functions that are available over there, which I believe is swim and fly. Once we have that, we can create an instance of the duck, which is duck, and we can perform action and pass in the duck. And this should be okay because the duck is actually conforming to both of them. If duck was only conforming to can fly, then perform action will give you an error that your protocol composition is not in a good place because it also needs to do can swim. So this is the protocol composition in Swift language. Do you know that in Swift language, protocols can be used as types? This means that you can declare a variable or a function parameter as a protocol type, and then you can pass in a value that is conforming to that particular protocol. Let's go ahead and take a look at an example. If I go ahead and create a protocol called animal, and it will have one single function, which is make sound. I will also have a struct, which is dog, which will be conforming to the animal. And then I will go ahead and also implement this. Now, what kind of a sound that the dog makes? Woof. There we go. And when we have dog, we should also have cat. So let's go ahead and add a cat. And cats are my favorite, so they're going to say meow. So we have two different structs, dog and cat, and both are conforming to the animal protocol. Now, if I go ahead and create a function called make animal sound, where you can pass in an animal, I can simply say the type, which is animal, which is basically saying that if you need to call make animal sound, you need to pass in the animal, and the type of the animal is not cat or dog, but it is something that is conforming to the animal protocol. So, which basically will be dog and cat. And then we can say animal.makeSound. And the reason that we can do animal.makeSound is that you are actually passing the protocol. And this particular protocol defined right there contains only one function called makeSound. So you can basically call that function on it. Next, you can go ahead and create a cat. And in the same way, you can create a dog. You can call make animal sound and pass in the cat, or make animal sound and pass in the dog. This is a good thing because the caller doesn't really care if you're passing in the dog or the cat. The function itself doesn't really care if you are passing the dog or the cat. It only cares that whatever you're passing, it must be conforming to the animal protocol. And that's what we're doing. We have the cat, which is conforming to the animal protocol. We have the dog, which is conforming to the animal protocol, and they both will work correctly. Now, if I go ahead and create a duck or something, which is not really conforming to the animal protocol, then I guess you can already tell that, I don't even know what the duck quack, Q-U-A-C-K. Okay, so if we create a duck over here, then I cannot really call duck over here. And the reason is simple. The duck is not conforming to the animal protocol. So this is how we can use the protocol as types. You can use them in the function parameters. You can have one or many. And this can be really, really important, really, really interesting, because you can consider a scenario where you want to send a message, but the message can be sent using a fax machine, using an email, using an instant messenger, using some sort of a Slack message. So if you create some sort of a protocol, just like animal, and you don't really care what person is calling, like meaning that the only thing you care about is that they are conforming to the messaging protocol, then you can simply call send message and you're done. And that same function can be used for all the fax machine and the email and the Slack message, whatever you want to do. And that is a really, really good. The function itself doesn't really know or care if this particular make sound is going to be called on the cat or dog. It just knows that whoever calls this make sound must be conforming to the animal protocol. So this is what we call protocol as types in Swift language. One of the really cool features of the Swift language are the protocol extensions. Basically, the idea behind protocol extension is that you can provide default implementation of the functions that are consisting in the protocol. Let's take a look at a very simple example. If I have a protocol called animal, which consists of a name property and also a function called make sound. Now, I can actually extend this particular protocol and implement the make sound function, which is pretty cool. And I can say sound of some animal. So what's the reason that I would extend the animal protocol and implement make sound? Well, one of the reasons can be that people who will be conforming to this protocol, they will all use this implementation, or you're just providing a default implementation, because if I create a struct, I can always have the option to overwrite it. So I'll say name, and I can overwrite the make sound, and now I can do whatever I want. So it gives, if I don't override the sound, let's say if I create a particular cat, and let's say that I'm lazy and I'm like, okay, I don't want to do it, not lazy, but I just don't want to implement this, then it's going to be using the make sound function, which is already declared in the protocol extension animal. Let's take a look at a very simple example. Dog equals to dog and whatever dog name is, like say Fargus. If I say dog.makeSound, then the dog struct itself does contain makeSound function, so that particular function will be called. But what will happen to the cat? Cat equals to cat, and then whatever, Tinku, and then cat.makeSound. Now this is the problem, right? The cat itself does not contain a function called makeSound. So what is this going to do is it will revert back to the default implementation of the protocol, which is makeSound, and it will simply say sound of some animal. Let's go ahead and say sound of some animal. So this can be especially useful when you are creating a protocol and all of the things that are going to be conforming to the protocol will use a default or the same implementation, that instead of going to every single person who is conforming to the protocol and implementing that method, you can simply go ahead and extend the animal and you can create that make sound function or whatever that you're doing. This is very common, and it provides you the default implementation of the make sound function, but it also provides you opportunity for your other structs or whoever is conforming to override it and provide their own implementation as the dog is doing. So this is the protocol extension, very, very useful, and hopefully you are going to be using this a lot. So definitely practice this a lot when you are learning Swift language. We will start by understanding the raw values in enums. So let's say that I have an enum called weekday, which is integer. And I go ahead and create Sunday, and I'll assign the value 1. Now, if I have some other cases over here, let's say Monday, and I have Tuesday, and Wednesday, Thursday, Friday. Now, the great thing about Swift is that since we are using raw values and since this is already assigned to be 1, and it is the raw value of integer, meaning each of these cases does have a associated primitive type value of 1 because it's integer. So Sunday is 1, Monday will automatically become 2. So if I go over here and print out the value of weekday dot, and I say a particular thing like Sunday, then we'll be able to find out that what that value is. So you can see that right now it's actually printing out to be Sunday, right? But what's the raw value of that? So raw value property is going to give you the number associated with Sunday, which is 1. But what about Monday? We didn't really assign any value over there, right? But since we assigned the first value to be 1, it's automatically going to be 2, 3, 4, 5, and 6, and so on. So that is how these things work. And obviously, we can have Saturday also. Okay, so if I go ahead and say Saturday, the raw value that will be assigned will be 7. But raw values are not only for integers. You can create, let's say, HTTP status code and assign the value strings. So maybe you have a status code of OK, where the value assigned is 200. And then maybe you have a status code of not found, which is 404. So it's really good that you can use these kind of raw values, and now we can have bad request, which can be like 400 or so. And you can use it just like the way that you were using it up there. So if I want to access, if I want to simply print it out, I will simply say HTTP status code dot, I will say, let's say not found dot raw value. And the raw value associated with not found is 404, so it simply prints out 404. You can use integer, you can use characters, you can use double floats, whatever you want. Now, one of the cool things that you can do with these raw values is that if you actually have a raw value, you can construct a particular weekday. Okay, so let's do something fun. I'm going to say day equals to 3, just a variable, just an integer, and that value is just 3. Now what I want to do is, can I use weekday? So if I say weekday, pass in the raw value, which is 3, and can I get something back, right? So can I get weekday back? So what will it actually return you when we are passing the day 3, which is the raw value? So if I go ahead and print this out, weekday, you can see it's going to give me optional of Tuesday. And the reason it is optional is that when you're constructing it right over here, when I actually type it out, weekday with raw value, this is actually going to be providing us the optional thing. So let's go ahead and check it out over here, optional of weekday. Okay. Oops. Oh, I have to type it again now. Weekday with a raw value. So we can probably unwrap it. And now we can print it out. Okay, so now we'll get the Tuesday. So it's kind of cool that if you have raw values assigned and if you want to construct the enum, then you can simply pass in the raw value and you will be able to construct enums. Let's take a look at another example. If I have something called, let's say, user role, which is string, and it is codable. Codable simply means that it can be serialized and deserialized. And we have maybe different roles over here. Let's say that we have admin and we have user. Okay. Now we have these different things. If I get a different role, right? So if I get a particular user role, so user role, I'll get from the user role dot admin. Okay. I can use the JSON encoder and I can also encode this value. Let's say user role. And this is going to give me some sort of a JSON data. Let's go ahead and print out this data, that what it is. Now, if you try to encode it, you will see that we won't be able to see the correct thing because it's going to return you the actual data. So the only thing you might be able to see will be simply the bytes. So if I go ahead and run this right now, you can just see 7 bytes, and that's pretty much it. And enums, this means it can be serialized and it also can be deserialized, meaning I can decode it by simply calling the decode function. I can pass in the user role.self, which is the enum, from JSON data, the one that we just did it, and now I can say decoded user role. So I'm just going to get back the actual user role over here. There we go, raw value. I think if you print out the raw value in this case, it will be admin because that is the same thing that we decoded or encoded. So these are the raw values. You can play around with it. It's kind of fun to have these raw values available to you. And it's definitely very, very powerful feature of the Swift language. Now let's go ahead and talk about associated values in enums. Now we did talk about when we were creating an enum, let's say compass, and it can have different options like north and south and all that stuff. But sometimes we want some additional data like north, like maybe we want to walk north like 5 or 10 miles, like over here. We want to walk a couple of miles. So how can we create those values? And those values are actually called associated values. So let's go ahead and see that how we can utilize enums with associated values. We're going to go ahead and create a enum called request. This will be like an HTTP request, which can be get, post, put, delete, and all that stuff. And we can provide a get. But we also need to provide the URL where you're making the request. So that can be the associated value. So we can simply say over here, string you're going to pass in, that will be the URL. Okay? And we're going to use the same thing. We can use post. In the post, we will have a string over here because the first argument is the URL, but the second argument can be some sort of a parameters. Maybe you're trying to pass in an array. So we can have like this. Now, how do we use this request? If we have created this request, how do we end up using this? So let's say that we have a function called makeRequest, and that particular function is a request. Now, since this is actually a request, which is an enum, you can always perform a switch on the enum. And now we can handle the actual URL. And you can do whatever you want with the URL. Same thing over here with the post. Since we have defined that the post will have two different parameters, the string and the dictionary, so that is exactly what we're getting. We'll take URL and we'll call it parameters. Now I can go ahead and print them out. I can say print, and I can say print the parameters. Or, I can do whatever I want over here, make an actual request, obviously. So this is a very important feature of Swift language, that it allows you to use associated values. You have already seen associated values before. Remember the result? This is actually using associated value, which is also generic type. So if we look over here, you can see that it takes in two types, a success and failure, but it is not like a particular string type, it's just a generic type. So we can also create, let's see that if we can create enum called result, or will it actually complain? So we can create a result called enum, which takes in a type, and on the success, we can use that particular type, and on the failure, we can use the failure type, which again, we don't really have the failure type, right? So we will have to be passing something over here if we are calling it error or failure or something. So if I run this right now, it is going to be okay because we are saying the error type. If I say failure over here, right, and if I try to run it, then it's going to be like, okay, what is failure? But error is an actual type, so I can actually pass error, and that's perfectly fine. So that is the result type that now you can use. So in the same way as we were doing something, let's say fetch data in a completion, and we can use the result type, and we can pass in whatever the type of data that we are going to be getting back, let's say string, and we can say, well, that's pretty much it. We don't even have to pass in the error because our result type doesn't really care that much about the error. Okay. All right, let's see what's going on over here. I think we can fix it. There we go. We're just missing some parentheses and that's it. So these are the associated values. Sometimes your enum will require some additional data, and that additional data is called the associated value of an enum. Do you know that in Swift you can have enums inside another enum? Let's go ahead and take a look at an example. Let's say that I have an enum called a restaurant. Okay. Now in the restaurant, I can have different things. I can have the name of the restaurant, which can be a case because all I can have is cases. I can have the rating of the restaurant, which can be double. I can have the location of the restaurant, which can be string. But the other thing that I can have is I can have a menu of a restaurant. So that can also be an enum inside the restaurant enum. So I can say menu. And I can have entrees, which can be an array of strings. Or you can have a different type if you want to. We can have desserts, which can have an array of strings, and so on. And also, obviously, appetizers if you want appetizers. So we can also have appetizers, which can be an array of string. And you can represent this particular menu by simply performing a menu and passing in the menu itself. So this particular menu, which is the case for the restaurant enum, will give you access to the menu enum, which you can then use. Now, how would you use it? Well, if you want to get the menu, you will say menu, which will be type restaurant.menu, and we can simply say entrees, and we can provide some sort of entrees over here. All right, so whatever your dish is, you can just provide that. Kind of cool that you can create this kind of a hierarchy. And just for the example, when I was working with Swift UI, when I'm working with SwiftUI, one of the things that I was using this particular approach of creating this nested things, nested enum, is when I was creating different routes. So let me go ahead and take a look at that example if it will work over here, but I will just post it over here so that you have an idea of what I'm talking about. Now, obviously, we don't really have anything called category, catalog routes and inventory routes, but you can see that routes is an enum and that contains other enums also. Okay. Now, obviously, in this case, we have a lot of stuff missing, but you get the idea. In a real app, you can also use this stuff. Okay, so I'm just going to comment this out. There we go. There we go. So nested enums, when you're designing nested enums, pay close attention to the hierarchy that you're trying to set, and then you can set that particular hierarchy using nested enums in Swift language. One of the cool things about enums in Swift is that the enums can also be conforming to a protocol. Let's go ahead and create fruit and make sure that it is conforming to equatable. And we can have different fruits, obviously. We can have apple, we can have banana, and we can have orange. This means that all of these cases are now conforming to equatable, and they can be equated, they can be compared against. So let's say that if I go and say fruit 1, and that can be fruit.apple, and I can have a fruit 2, which can be fruit.banana. I can go ahead and compare them. If fruit 1 is equals to fruit 2, then we can say that fruits are same. Else, if they are not same, then we can simply say fruits are not same. Okay? So if I run this example right now, since apple is not really equal to banana, it will say fruits are not same. But what about if both of them are apple? And since they are equatable, they will be able to compare with each other, and this will result in fruits are same. So protocol conformance is also available in enums, which is kind of cool when you're working with Swift language, and you can use it to create these kind of things. It's not like only one. I mean, you can do like hashable, or you can have your own protocol also. All right. So, but right now we're just using equatable because we actually do want to compare equality between the different cases or different basically fruit enums that we're creating. But this conformance can be based on different things also. All right, different protocols. So this is the protocol conformance in enums in Swift language. Do you know that in Swift language, your enums can also have static functions? Let's go ahead and take a look at a very simple enum called HTTP method. This can have cases like get, we can have post, we can have put, and obviously delete. Over here in the enum, we can actually create a static function which will be on the type enum, which is HTTP method, and we can say all methods. Now you can name your enum anything you want, and it is going to return us HTTP methods, all the HTTP methods that we have. And now we can return an array of get, post, delete, and also put. Now, how do we actually call this particular function? Well, HTTP method, which is just the name of the enum, and we can say all methods, it is going to return you an array of all the methods, so all HTTP methods. So it's kind of cool that you can have this kind of a feature built into the Swift language. All right. Now, sometimes another thing to cover over here is that sometimes you have these get, post, and put and delete. And yes, I can go ahead and put a string value to it and assign the value, and I can access it using the raw value, which we learned earlier on. But sometimes you can also create a property, title, or anything you want, and perform a switch on yourself, meaning the HTTP method itself. And for each case that you can handle, you can return the keyword for that particular case. So this is also very useful when you are working and you want to not assign some associated values, but you want to create a property that will return you a more descriptive value of that thing. Now you might be wondering that why can't we just assign the values over here, and that is fine. I think you can if you want to assign the values over there, but sometimes in cases for display purposes, especially if you are using these enum values and you just want to display it on the screen, I personally like to have like a title property or something like that that will return me the actual text that I want to display. Okay, and now if I want to call this title property, I just have to create, let's say, HTTP method equals to HTTP method.get, and I can say HTTP method.title, and I will get that particular title, which in this case will be get. So apart from creating a static function inside the enum, you can also create these properties that will give you additional information which will be based on the cases, and this can do some calculation also if you want. So this is the static property as well as a static function as well as just a normal property for enums in Swift language. In the last lecture, we covered that you can create a static function for your enum, but you can also create computed properties, which we also covered in the last lecture a little bit, and I want to focus on that a little bit more. Let's say that we are creating an enum called weather, okay? And it has a couple of different things like sunny, and you have a temperature, which is double. And you also have rainy, where the rainfall, and you have some value over here. Now, based on the temperature and based on the rainfall, we can probably create some sort of a computed property that can tell us that whether the weather is nice or not. So this property is a computed property because it only computes and returns. And we can perform a switch on the self just like the last lecture, but in this case, we are going to take a look at the temperature. So we are going to get the temperature over here. Actually, this will be simply double. I'm not sure why I'm passing all of that stuff. There we go. And we will get the temperature. Based on the temperature, we can simply return that if the temperature is greater than 70, then we will return true, and I guess else it will be false. Same with the rainfall or rainy. We will say rainfall. Okay, and based on the rainfall, we can say if the rainfall is less than 0.5 or anything, then we can return true over here. So this is the computed property. Now we can actually go ahead and use it. So weather.sunny, and we can pass in the temperature, whatever temperature we want to pass. Let's say if we pass in 80, and then we can say weather, and we can print out the computed property over here. So computed properties can be really useful when obviously when you're trying to compute something. And in this case, we are trying to compute something which is whether it is a nice weather or not. If I go and change this weather to 56, which is actually nice for me, then it will return false. Okay, so these are computed properties in the enum in Swift language. Hey, congratulations for completing this course. I am so proud of you. Now your next step is to just keep on learning. Go to adamsharp.school, click on courses, and you can find dozens and dozens of courses over there. If you want to start with a free course, then scroll down and you'll be able to get access to the SwiftUI Fundamentals course. This is again a very beginner-friendly course that you can get access to. It's completely free for you. So make sure that you register for that course. And once you are done with SwiftUI Fundamentals and Swift Language Fundamentals, well, then your next step can be any course that you want to take. All of these courses are standalone, meaning you can just learn on their own. Thank you so much, and make sure to like and subscribe.